Hi everyone, this video is going to cover derivatives of inverse functions. We actually took these notes in class today, so this is just kind of a refresher, or if you were absent from class and just want to you want to catch up, that'd be great. Or if you were a little confused in class and just need a little bit more of an explanation. So let's first review what inverse functions actually are. So let's say we have y equals 2x, and we want to make a table of values. So let's say I plug in -1, 0, and 1. So if I plug in -1, I would get -2. If I plug in 0, I would get 0. And if I plug in 1, I would get 2. Well, the inverse of y equals 2x is y equals 1/2 x. If we look at a table of values here, then if I take the inputs of my original and the outputs of my original, they're going to still appear in this table, but they're going to be opposite. So if I were to plug in -2, 0, and 2, I would get output values of -1, 0, and 1. So we can see that these inputs on my inverse are the outputs on my original, and the outputs on my inverse function are the inputs on my original function. Inverse, remember, just means the opposite. So if we think about inverse operations, if we're adding, then the inverse would be to subtract. If we're multiplying, then the inverse would be to divide. So inverse functions, it's kind of the same thing. They undo each other. So the relationship that we need to remember about the inputs and the outputs is that with inverse functions, the inputs and the outputs switch. So whatever we plugged in before now becomes an output, and whatever was an output before now becomes an input. So a more mathematical way to say it is, let's say we've got this function f of x equals y. All right, and we know that g of x is equal to f inverse of x. So in other words, g is just the inverse of f. Then we know that g of y is going to equal x. So again, the inputs and the outputs switch places when we talk about inverse functions. That's really what that means. So let's figure out how to actually take the derivative of an inverse function. So in pretty much all of these examples, what we're going to be told is we're going to be given something like g of x equals f inverse of x, and we want to find g prime of x. So in other words, we want to find the derivative of an inverse function. So the first thing that we're actually going to do is we're going to rewrite this so that it doesn't have an inverse function anymore. So remember, inverses are the opposites. They undo each other. So if we were, say, adding 5 to both sides, if we subtract 5 from both sides, it would get rid of it. So if I'm doing an inverse function here, I'm going to take f on both sides. And I know that that sounds a little weird, but I'm going to show you what I mean. So I'm going to say f of g of x equals f of f inverse of x. So on the one side, I now just have f of g of x equals, well, f and f prime undo each other, and we're simply left with x. So we rewrote this same equation, but we wrote it without any inverse functions anymore. And now we can actually just take the derivative. So if I want to take the derivative of f prime of g of x, I know that this requires chain rule. So I'm going to do the derivative of the outside, so f prime of g of x, times the derivative of the inside, which is g prime of x, and that's going to equal the derivative of x, which is just 1. And I'm going to go ahead and solve for g prime of x because that's what they had originally asked me for. So I'm going to divide both sides by f prime of g of x. So I get g prime of x is equal to 1 over f prime of g of x. And that's how I actually find the derivative of an inverse function. So this isn't a rule. This isn't like product rule or quotient rule where we just memorize something. This is actually going to be an entire process that we want you guys to go through so that you can get to the derivative of an inverse function. So we're going to write out just some quick steps to help us remember what it is that we're going to do. So step 1 is going to be rewrite the problem. Without inverses. Hopefully you guys are okay. This W/O means without. Sorry. The next thing we are going to do is we are going to actually take the derivative. Using chain rule. Right, that's where this g prime of x actually even came in, was from the chain rule up here. Step 3 is going to be to solve for the required derivative. So in this case up here, that was our g prime of x. That's what we needed to solve for because that's what they had asked for. And now we didn't do it here, but step 4, because most of these problems, it's what it's going to ask us to do. Step 4 is actually going to be to substitute values and actually calculate whatever it is they ask for. So those are going to be the 4 steps that we follow every time we do one of these inverse problems. So let's actually take a look at a real example. So looking at example 1, there we go. Let f be the function defined by this. G of x is equal to f inverse of x, f of 1 equals 10. What is the value of g prime of 10? So the first thing I want to point out here is we're given this function, and we're also told that g of x is equal to f inverse of x. So we're going to go ahead and just right away get started with step 1, which is to rewrite the problem. So if we know that g of x is equal to f inverse of x, then that means we can go ahead and actually take f on both sides, right? We're going to undo it here. So f of this stuff, f of this stuff, and we end up getting f of g of x is equal to x. So there's our step 1. We had to rewrite the problem without any inverses. Step 2 now is going to be to actually take the derivative using chain rule. So the derivative of f of g of x is f prime of g of x times g prime of x equals the derivative of x is 1. So again, there's our chain though, the g prime of x. Step 3 is that we want to solve for the one that we were looking for. Since they're asking for g prime of 10, it means that I need to know what is g prime of x. So that's what I'm going to solve for. So g prime of x is going to equal 1 over f prime of g of x. And finally, step 4 is going to be to substitute some values in. So this is where we're going to have to think a little bit. If we want g prime of 10, g prime of 10 means anywhere we see an x, that's where we're going to plug in a 10. So it's going to be 1 over f prime of g of 10. And now we need to think about how to actually go about simplifying this. So we know this original function f of x, and we also know this original point f of 1 equals 10. In order to simplify what it is we're looking for here, we need to know what is g of 10. Well, g is our inverse function, and this point f of 1 equals 10 is actually part of our original function f. So the original is f of x, and we were given the point 110. So what we need to think about is if that's the point on the original function, then on the inverse function, g of x, we can just flip-flop the input and the output. So this is actually the point 10, 1 when we think about the function g of x. So that means g of 10 is actually 1. So g prime of 10 equals 1 over f prime of 1. Because again, g of 10 is actually equal to 1 since we flip-flopped the input and the output. So now let's see, if I could just figure out f prime of 1, I would be good. So if I know my function, I'm going to just take the derivative. So f prime of x is going to equal, let's see, 3x squared plus 7, and then the derivative of 2 is 0. So if I want f prime of 1, that's going to be 3 times 1 squared plus 7, so it's going to be 10. That means then that g prime of 10 is going to equal 1 over f prime of 1, which was 10. So this is my answer there. I know it's a lot of thinking, but we followed those 4 steps, and once we got to here, we had to think about what other information we were given and how do we actually use it. So let's do one more example together and make sure we know how to do these 4 steps. So let f be the function defined by f of x equals 7x cubed plus natural log of x cubed. We've got g of x is equal to f inverse of x. And we were given f of 1 equals 7. What is the value of g prime of 7? So we're going to need to actually find g prime. So let's do step 1, which is to rewrite. So g of x equals f inverse of x. That means then that f of g of x is going to equal x. Step 2 is to take our derivative using chain rule. So that's going to be f prime of g of x times g prime of x equals 1. Sorry about that. Step 3 is we need to solve for g prime. We decided that's what it was we were looking for. So g prime of x is going to equal 1 over f prime of g of x. And step 4 means we're going to substitute in what we know and figure out what it is we're looking for. So if we want g prime of 7, then that means we're looking for 1 over f prime of g of 7. So we need to first figure out what is g of 7. So if we look at some of the other information we're given, we were told that f of 1 equals 7. Again, f is our original. So if f of x is the original, and that's the 0.17, then if I think about the inverse, which is g of x, then I know I can flip-flop that point, and it's going to become the 0.71. My input and output switch when I look at inverse functions. So that means that g of 7 is actually this value 1. So g prime of 7 is going to equal 1 over f prime of 1. Now I need to figure out what f prime of 1 is. Well, that means I need f prime of x. So here's my original function f of x. So f prime of x is going to be, let's see, 21x squared plus, now if I want to do the derivative of the natural log of x cubed, I know that that's going to require some chain rule. So that's going to be 3 times the natural log of x squared times the derivative of natural log, which is 1 over x. So if I want to plug in f prime of 1, let's see, that's going to be 21 times 1 squared plus 3 times the natural log of 1 squared times 1 over 1. Hopefully you guys know that the natural log of 1 is 0. That actually makes this whole thing cross off to be a 0, which means f prime of 1 is just 21. So when we do g prime of 7 then, it's going to be 1 over 21. And there's our final answer. I know this is a lot to process. If you can get through those 4 steps first, then that's half the battle, and then it's figuring out what to plug in for your g of x sometimes. It can be a little tricky. If you've got questions, please make sure you wrote them down. We're going to do tons and tons of practice on this stuff. Thanks for watching.